Okay, perfect. Thanks everyone for showing up to today's session on Git and partially also GitHub and how this whole version control works. We're super excited to have Frie here today to tell us more about this. Before we're getting started, most of you probably know us. We're the Social Science Data Lab based in Mannheim at the ANSYS, the Mannheim Center for European Research. And we also host the blog Method Bites, where you find lots of different tutorials on data visualization, Bayesian statistics, web scraping, all these things there. And this whole setting is co-organized by me and by Dennis Cohen, who is also here today, as well as Julian Bernauer and Nick Baumann. And without any further ado, I'll leave the floor to Frie. Thanks for being here today.
Hi, everyone. I just have like a Wackelkontakt at my monitor, but it's back now and I just don't touch it anymore. Hi. So yeah, thanks for the nice introduction. My name is Frie and I want to talk to you about Git and also give a little Git Essentials workshop. The first part will be more of an argument that I want to make why social scientists should, or researchers in general, but especially social scientists should use Git and GitLab or GitHub in this case more often. And then we will do like a small walkthrough through the typical workflow of Git. So before I introduce myself, I want to know who are you? I will put this link into the chat as well. But you can also go to menti.com and enter this code here. And it should show like a question, should show like this. I hope this works. Yeah, and we already get the results coming in. Yeah, I suppose something like this, yeah, would happen. But the postdocs are catching up. No, not so much. Okay, that's okay. Thank you for answering very quickly. I think most of you have answered by now. And yeah, this kind of confirms who I was expecting, like a lot of PhD students, postdocs, some postdocs. Sadly, no professors or junior professors, because I would love to see them here because they have typically the power to introduce kind of changes in infrastructure and stuff like that. But as Cosima said when we were talking before the call, it can also be a bottom-up thing. So I hope you will be then the messengers to spread the word in your chairs and working groups. And also props to the one master student. Very cool that you are here. Okay, let's get back to the presentation. So who am I? My name is Frie. I'm kind of like a data scientist, data engineer. I'm a data for gooder. What that means, I will talk like in 1 minute. I would also say I'm a software developer from time to time. In general, I really like coding a lot and programming. So yeah, I don't have a fixed label. I just do a lot of stuff with code and data, but not necessarily the modeling part, more of the surrounding things like yeah, data engineering. Like a very short CV, because that might be relevant to why I'm here and why I'm kind of like maybe qualified to talk to you. I have a background in social science. I studied politics and public administration in Konstanz, and then I studied a master in social and economic data analysis, not science analysis. Yeah, so I also know some of you personally, and yeah, I come from, I think, a similar space than MCES is. And yeah, so I can relate to a lot of you, hopefully. And yeah, and after my master's, I worked 2 years in IT consulting, where I learned a lot about Git, and I had to use it daily. So that's where I got my Git skills. And now I work at CorrelAid, which is a data for good network. And I work kind of as the coordinator. So I don't code as much as I used to, but I still use Git very often. And you can find me mostly on Twitter at Ameisenstraße. That's my handle, and you can follow me there. So why am I here? I like Git, I like GitHub, I like GitLab. I think a lot of people would benefit from using it more, or using it in the first place, especially social scientists, researchers, or researchers in general. So let's start with the first part, which will be like more of a motivational kind of argument why you should adopt Git, because it's quite an investment to do this, and I want to give you some good reasons, also maybe to convince your professor or your working group leaders why should we change this up, because change is always difficult and always like, yeah, something which is not easy to achieve, I guess. And so first of all, to just establish some terminology, what is Git and what is GitHub? Git is a version control system, a VCS. You can think a bit like, it's a bit like the restore feature in Microsoft Office. So if you have worked on a Word document before and then you somehow Word crashed, and then you can restore your work, right? And so Git is a bit like that, but it's way more powerful. So you can not only restore your work from like 15 minutes ago, but you can also restore your work from like 2 months ago, 3 months ago, 1 year ago. So you can go back in time way further. There are also other services like Dropbox or Google Docs who have version control systems built in. Typically, this is then called version history in those systems. So you might have used version control in another service already. In contrast to those version control systems in Git, you actively have to save things. So this is a difference between, for example, Dropbox. You actively have to save things in Git to have those version controls. And GitHub is kind of like Dropbox for Git. So you have Git on your machine, on your local computer, and then you have your project on GitHub or GitLab, but we will talk about GitHub here. And so it's kind of like the cloud for Git projects, but it has no automated sync. So in Dropbox, you're typically used to things syncing automatically. In GitHub, this is not the case. We will talk about that later. This might sound like it's a disadvantage, but in my opinion, it's also an advantage. And GitHub comes with a lot of collaboration and project management features, which are really, really helpful in my opinion, and one of the main reasons why I think you should switch to Git and GitHub. And which is also a nice benefit, it's a social network of some sort. So everyone has a profile, and you can see what are other people doing, what projects do they have. You can follow their projects, and you can also suggest changes to their projects. So it's a very nice kind of like place, I guess, for research as well. Okay, so why should you use this? I already hinted at some things. My main argument is kind of like that learning and using Git is complex. I don't want to deny that. It's a complex tool. I've been using it for like 4 or 5 years, and I still am like sometimes a bit overwhelmed by the complexity. But what I think we tend to forget is that the systems and workflows we are using right now without Git and GitHub are also complex. We just got used to the complexity. And I will give you some examples in the next slides, but just keep that in mind. And I just want to, I don't know, make you reflect a bit on how you work on code and how you collaborate on code, and whether this is not also very complex in a way. But ultimately, you of course, you decide which system or which workflow works best for you. I'm just here to propose an alternative to what you might already know. So let's go to the first reason, which is version control. I think I already talked a bit about version control. So here are 2 examples from my old student life when I was studying still. So the first one is from my bachelor thesis. Second one is from my one of my student research assistant jobs. And so what do we see? So we see files which are called like droppedcode.r. I used to have this file in all of my projects, and there I would just dump all the code which I didn't need anymore, but I was not sure whether I could delete it, right? I was like, oh, maybe I might need this in the future. So I can't let it go. I need to keep it. So this was something I did a lot. Then we have typical, very typical, I guess, we have something which is modified, and then we have modified one. So I don't know what's the difference. I didn't look into it, but apparently this was necessary. Then we also have something called final models. On the right-hand side, we have similar things. So we have something called data wrangling, and then we have something called data wrangling _old. So again, probably the same thing. I rewrote the code in some way, but I was not sure about deleting old code. And then also maps too, of course, because map, I don't know, was not good enough. I don't know, maybe I didn't like the colors or something like that. So that's a bit messy, right? And looking at it now, I'm like, oh, all those files, and I don't know. Especially now, I don't know what's the difference here. I would have to go through the files manually and compare, and then see what has changed. And in Git, whenever you do one of those save points in Git, Git makes a snapshot or a backup of all your files, and you can restore that backup at any time. So this means that when I used Git back then, I could have deleted the old code because it would have been in one of those old backups. So I could have, in doubt, I could have gone back and just restore the backup and get my old code back. So this is like one of the reasons why Git is very powerful. You always can go back in time and get your old code back if you need it, right? This is typically you don't do that, but it just gives you a peace of mind, and you can then delete old files and just have only the code which is relevant right now, which is like the most up-to-date version in your folder. And those backups are very light and very compressed. This is also very important because you might think, whoa, it does a backup every time. This must be like huge, right? But Git is very cleverly designed. So it's actually not a lot of extra storage associated to using Git. So I briefly want to talk about the notion of a commit because it's so central to Git. So a commit is the Git equivalent of a save. And Git committing is an operation that acts upon a collection of files and directories. So a commit is, as I said before, it's a save point. And whenever you make one of those commits, Git makes a snapshot. I also said that already, of the current state of the repository. In contrast to like a save, which you know from Word, where you hit, I don't know, Ctrl+S, right? You save your file, or in RStudio, you save your file. If you make a commit, you can include multiple types of changes. So in one save point, you can have edits of files. So it's something changed in your code. You can have new files, you can delete files, or you can rename files. So saving something in Git, making a commit means you can have not only one change, but you can have different changes in one save point. And if we look at commits, we will do that later in the practical part. You will see what has changed in this commit. So, and this is called diffs, so differences. And yeah, we will have a look at that later. Yeah. So take away a save in Git, you make a snapshot, and you can also have different types of changes in the commit. Okay, I briefly want to show you an example. This is one of my personal projects, which I did for CorrelAid. And there were 3 different versions over 3 years. So this is a long running project, and I come back to it from time to time, and then I see my old code and I'm like, oh, this is horrible. I have to rewrite it from scratch. And then I switch it all up basically. So first I did it in R, then I went to Python, and then now last year I went back to R. So it has seen a lot of changes, right? And if we think back to my old projects at university, that this would mean that I would have like maybe 3 folders like R, Python, R. But because I was using Git for this project, I just deleted all the code when going back and forth. So let's have a look at those commits. So this is not one commit. This is what is called a history of commits. You can always see this on GitHub. If you go to the repositories, you can see all the commits made. And here we see a lot of old commits. So this is from when I did the first switch. And here, let's go to this commit here, which is called delete old code. So this indicates already I did a lot of deletions. And you can see here, I changed 9 files in this commit, and I added nothing. I added no line of code. I just threw away a lot of code. And this is always very satisfying, I can guarantee. If you haven't deleted code in your life, deleting old code is very satisfying. So I deleted 414 lines of code, and yeah, we can have a look. I mean, this is like the old R file. And yeah, every time if you look at a commit and something is red, this means that it was deleted. Okay, and then let's have a look at the commit which was made like last November, where I did the reverse. So I went from Python to R. I deleted even more code. I mean, 2,600 lines of code were deleted in this commit. And yeah, so this just shows that I don't only talk to you about deleting old code, I also do it, right? And it's very convenient. And I could always go back, right? If I was now, okay, I want to do it in Python again, I could still restore my old code and start from there. Okay. So this was the first reason. Now you are again, but I have to go to the Menti. I think I have to go to the next slide. But yeah, now I want to know from you, how do you collaborate with people on code? Just you don't have to write an essay, but maybe if you, oh, it didn't work. Did it change? Okay, let me see. Present. We should always change. Okay, I don't think, yeah, no. Maybe if you could type, I don't know, 1 sentence, where and how do you collaborate with people on code? Do you use Dropbox? Do you write emails? Do you write comments in code? Or do you just Zoom or something like that? So where do you and how do you communicate with your collaborators about code? If you do so, if you have any collaborators, if you just do it for you, that's a different story, right? Mostly Dropbox, emails, or comments in our code. Yeah. Nice, okay. WhatsApp. Nice. Okay, that's very interesting. Thank you for the submissions. So I was not too bad with the Dropbox thing. That's nice to hear. Okay, RStudio Cloud, that's a very advanced solution. Okay, emails. Okay, emails, Slack, Zoom calls. Okay, I see. This kind of confirms what I was thinking as well. So let me go back to my slides and go into presenter mode again. So second reason why you should Git and GitHub is communication and collaboration. And I already said this is kind of like my main reason why I think everyone should be using Git and especially GitHub. So I don't have access to my old university emails anymore, but I remember things like this, right? So I'm a like student research assistant, and I have worked on my things, and then I write an email, dear Professor X, I uploaded the code. You can find it here and there, and I did the following, and then I do a bullet point list of all the changes that I've made. And then I also ask about my contract because I'm writing an email, right? That's how we write emails. So we just, we don't want to send a lot of emails. So we just write one big email. And then Professor X answers, dear Frie, thank you for the update. And then he does this thing where she or he does this like inline comment thing, right? And so they copy my email and then they put their comments underneath. And then at the end, they also write me about my contract. Yeah. So and I really don't like those emails because they get so long. But anyway, why is this inconvenient, or why could this be inconvenient from my point of view, at least? So first of all, the code and the discussion about the code are separated. So whenever the professor or I have to, we always have to have two things open, right? So we have to have the code open, and then we have to have the emails open, and then we have to match, where does this change what the student described, where does this actually take place in the code? And yeah, so this is the first inconvenience. Then I think it's also kind of hard to know when something is agreed upon. So if we go back to the, is this sufficient? Is it like a good idea comment? Is this now agreed upon? Is this really like something we do now? Or do we have to check again in person? Maybe let's wait for the next Zoom call. So it's just not very like formalized. And finally, I mean, this should be obvious, it's very hard to retrace decisions retrospectively. So let's say you are looking at some code and you think, okay, why are we doing this like this? And hopefully you have some comments in the code about this, because that would help. But maybe you might have to go back to your emails and then have a look at the emails which you wrote, I don't know, with your professor, and you have like a lot of emails with your professor because you collaborate with them on a lot of things. And then you have to find the emails where you were actually talking about code. And then you have to find the emails relating to this specific code. And yeah, it's just, in my, I don't know, I imagine this to be very, very hard and very, yeah, very annoying. So how does Git and GitHub help here? So first of all, we have commit messages, and you already saw a commit message when I showed you the commits. So this is all the stuff, just this very short description here. This is called the commit message. And this is from the repository from the CorrelAid website. And I mean, it's not always very informative, but at least you get some context what's happening in the respective change. So here, something with an event, then I did something podcast on the navigation bar. There was added a new event for April. We update the chapter Cologne chapter. I added a blog post here. So it just gives you like a very rough idea of what has happened in the commit. Then we have something called issues, which you have in your repository. In your project, you can have kind of like a to-do list of things. And this is kind of more project management, but you can also go in here and you can have a description of the issue. And then people could also discuss this in here. So you could have like problems, for example, define some problem, and then people could discuss it in the issue. And then you can also arrange those issues in kind of like a project tracking board. So some of you might know Trello, maybe. So this is kind of like a Trello board in GitHub. So this is more about project management, but it also helps with the discussion, right? And you could have discussion in issues, for example. One very important feature of Git relating to communication and collaboration are branches and pull requests. And branches, we won't come to that today, unfortunately. It's a bit more advanced, and but I wouldn't call it advanced. It's kind of like intermediate. So if you know the basic Git workflow, what I hopefully will be able to cover today, then the next thing you would, I don't know, work on or learn would be branching. So Git branches allow you to work in parallel. So as you see here, so it looks like this in a visual way. So this is like the main branch, and then you can branch off and you start working in parallel. And everything that happens on the main branch does not affect your workspace, kind of. So this is very useful because then you can test something out and just work on some code. And if it works, you can put it back into the main branch. And if it doesn't work, you can delete the branch, and nothing has happened on the main branch where you keep your kind of like your good files. And then, which is something very, very popular on GitHub, which is called pull requests. So this happens when you want to do this merging back into the main branch. You can make a pull request, and a pull request is kind of like a suggestion. So you say, okay, I've worked on my branch, and now I want to merge it back into the main branch where you have the good code, the working code. And then you say, you open a pull request and you say, okay, this is not a good example, but you would put a proper description here, what you have done on your branch. And I mean, this is not too bad, right? Fix ordering of bar plots in template, add a column that keeps the project applications, something. So you put a description here, and then this is not merged yet. This is just your suggestion, what you want to introduce. And then people can also comment and they can discuss. There is a review functionality. So it's very, very cool what you can do in those pull requests. And you can then discuss it, and then you can fix the stuff that your collaborators have suggested, and then at some point you can merge it. Okay, because I don't have a lot of collaborators at CorrelAid, I also want to show you a more realistic example. So this is in dplyr, and here Romain, he also makes a pull request, and he references the issue that will be fixed. And then there's some discussion going on. Hadley Wickham reviews something. There's a lot more discussion going on. And yeah, it's not merged yet, so it's still open, but at some point it will be merged into the dplyr main branch as well. So this is how you can use GitHub and especially those pull requests for like more for communication purposes. Okay, I will have to be a bit more quick with the third and fourth reason because we want to do some more practical stuff today. The third one is just about public presence, open science, all this stuff. So I already said on Git, you can have a profile, you can have your repositories public if you want to. You don't have to, they can be private. But if you want to, you can have a public presence for your project on GitHub. And so this is a bit more permanent, in my opinion, than just sharing like a Dropbox link, for example. And it's also, people will find it if they know your GitHub profile, they can easily find it as well. And one example which I found is that, for example, Pablo Barbera, I think he's quite famous with the Twitter stuff. I used his paper. he also has a GitHub repository for this very famous paper with the ideological positions with Twitter data. So he has all the code here. You can also have some discussion or submit problems with the code. So this is just very cool from like a publicity and open science perspective. And then fourth, this is like a bit cheeky, but I wanted to include it. I think you can also get better Hiwis if you use something like Git and GitHub, because I don't know about Mannheim. In Konstanz, the very good coding Hiwis were kind of sparse, a sparse resource. Maybe that has changed. Maybe it's different in Mannheim because everyone is so clever. But yeah, and Git and GitHub is very relevant job skill for data scientists, for aspiring data scientists. It's kind of like the bread and butter of data science, of coding in general in industry. So if you work, or if your chair works with like a stack which is relevant to students, this will make your student research assistant jobs very attractive. At least it would have been for me. Especially, I think, if you compete with kind of like Werkstudenten jobs in industry, where they probably work with more like modern or best practice standards. Okay. Summary: learning Git and GitHub is switching your workflow is complex, and it is an investment. But the existing workflows are also complex and confusing, and not, in my opinion, not very efficient. But yeah, this trade-off, of course, exists, and change is hard. And so I don't think it's bad if you keep working like you do right now. This is totally fine. You just have to, maybe it's worth to think about whether this is like the best way, and whether learning this would be more efficient in the long run. Okay, the reasons, my subjective reasons: version control, communication, bring the communication to the code and not have everything scattered, and more visibility for your project, and better Hiwis. So I'm a bit behind on time, but not too much. So I will take like a sip of water. You can all take a breath, and then I will continue like 20 seconds. I just have to collect myself. But yeah, you can maybe, if you have not already, you can, I mean, I hope you followed the instructions. If you have not, you should create a repository for yourself if you want to follow. But you need a yeah, exactly. So Cosima has also posted the link again. But yeah, if you haven't already, you should also create a new repository for yourself and call it git-tryout, and then make it private and tick this README file thing. But this only works if you have a GitHub account. So if you don't have a GitHub account, I think it's kind of too late now. You will just have to watch and do it later, maybe, right? You will have the recording, and you can then follow with the recording. Okay. One little disclaimer: we will be using RStudio here. But most common and universal is the command line interface, which is what you use in the scary command line. I will also show this maybe at some point today. So this is the most universal thing. RStudio works fine. Yeah, there's also some dedicated Git clients like GitHub Desktop, Git-Kraken, which is good if you're a student, or I don't know, PhD students might also get this for free. This is very nice. I used to use it a lot. It's very user-friendly. But every major like kind of IDE also has a client. So we use RStudio today, which is okay. And it works for like, I would say 80% of the stuff that you need to do in Git. This works very well. but it has lacks in some aspects. So the merge conflict tooling, some advanced features are missing, and then you will need to use the command line for those things. And I also like Visual Studio Code together with the Git Graph extension, which is open source, so you don't have to pay anything. Okay, but let's get started for real now. Authentication. Everyone, I hope, who followed the tutorial or the kind of instructions have already done that, and we won't do this because this always takes a lot of time. We won't do it today. If you haven't followed the instructions, you can do this after the workshop and then come back to this video. So just to clear this up really quickly, there are 2 ways to authenticate with GitHub. So, and the purpose is that GitHub needs to know who you are. In order for your laptop to communicate with GitHub, GitHub needs to know that you are operating your own computer, that you are connected to your GitHub account. And so you can use 2 methods here. You can use HTTPS, which is kind of like username and password, which is very easy to understand. And that's what I also put into those instructions. Probably it didn't feel so easy, but it's kind of like the easier of 2 options. Yeah, actually, we don't use password anymore. We now use the personal access token for security reasons. And you store this personal access token in a credential store. This is this core manager thing that you might have installed now, so that we don't have to enter it over and over and over again, because that's quite annoying. And the other option is to work with a key pair, and this is from public key, private key cryptography. And then you clone the SSH links. This might sound very abstract, so I just want to put it here for so that it's kind of like complete, and that you are informed that there are always 2 options to authenticate. And if you run into weird authentication errors, it might be that you are not authenticated with the method that you are trying to use. Okay, we skip this, and now finally do something. We download data. And here we have to talk about forking and cloning. So first of all, what's a repository? A Git repository is a virtual storage of your project. It allows you to save versions of your code, which you can access when needed. I already explained this a bit in the first part. And this repository can live at several places. So you typically what we have seen now, it lives on GitHub, right? I showed you some GitHub repositories, but you can also have a local copy on your laptop. So repository can live at several places, but it's always connected, right? If I download my repository from GitHub, it's kind of connected to the GitHub repository. And to download something from GitHub, initially, kind of the initial download, we do something called cloning. Forking is also relevant, but we can, for now, it's not relevant today. It might be relevant in some other context. So let's focus on cloning. When you create a repository on GitHub, it exists as a remote repository. It only exists on GitHub. You can clone your repository to create a local copy on your computer and sync between the 2 locations. Yeah, that's what I just also said, that it's kind of connected, right? Okay, how do we clone a repository in RStudio? I would recommend, there are several ways to do this, but this is what I would recommend to do if you're starting. You go to the top right corner in RStudio, and then you will find the project drop down, which is, hopefully you know, RStudio projects. And then you choose new project and then select version control, follow the dialog and use the URL of your git-tryout repository. And then RStudio will clone the project. So RStudio, where's my RStudio? Okay, I already have opened it, but I would do it like this. So you would go here and then new project, version control, git, and then the URL is the link, just the link from the web browser. And so the first task is to do this. To clone your git-tryout repository, if you have one, hopefully. And if you give like a thumbs up, that would be very helpful if you manage to do that. And in the end, it should look like at my place, on my screen. So this should be open as a project, and you just have the git ignore and git something here.
And for those who did not create the repository on GitHub, I think there was the link to github.com/new.
Exactly.
And this is the one that the others can use, right?
No, this is where they create a new repository, right?
Sorry, I thought that was, yeah, sure. That makes sense.
No, I mean, they can't push to anything, so it would not make sense. I mean, I can send them a link to my repository. Yeah, but if you go to github.com new, you can also quickly create something. So I could create something blah, 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 and make it private, add a README, and then create it. And then, yeah, you can also use this link here to clone. So it's very quickly to create a repository. Okay, if maybe you can also write in the chat if you have cloned it. Okay, oh yeah, thumbs up. Alex has thumbs up. Okay, I think I won't wait for everyone to finish, but I think like a sufficient amount of people have finished this. That's good, and I think the rest will catch up in very, very quickly. So let's continue. So now you have your repository also on your machine, and now I want to talk a bit about what you do on your local computer. So the local workflow of Git. And yeah, this is two terms that you have to know is kind of add and commit. Commit, you already know. So a commit is this kind of save point in Git, but it's also an action in Git. So whenever you create a commit, you call this I commit something. Okay. But first, let's have a look at some commits. And you do this by looking at the history, the Git history. And I also already showed you this on GitHub when I showed you the commits from my old, where I deleted all the code. You already had like a very short glimpse at a Git history. But now you can also look at the history of your own repository that you just cloned. It will be very short, but so it would, realistically, it would look more like this, like here. This is one of my own repositories, I guess. So you have all the history of commits, all the commits that you made. So the first next hands-on is kind of like investigate the commit history of your repository. And how do you do that? You go to the Git pane, and then you click on the small clock icon to open the history. And then you should close, I guess, the extra window once you have investigated enough. I mean, there's not a lot to investigate there because it's a new repository. But yeah, just to get you familiar. So the Git pane is always here. So you have the environment, history, connections, and then you should have Git. If it's not there, you might have to troubleshoot after the session because it should be there in RStudio. Yeah. Okay, so you click on this clock and then you probably see not so much, right? So looks probably like this. Okay, not a lot here, but what we can see is that something was added. So something is green, and was also made by you, right? Even though you didn't make a commit actually. This was GitHub, it made it for you. Very nice. So you already have a commit there. Okay, everyone should have probably made this. So this was easy, right? But how do you make a commit actually? This is now interesting, right? Because you also want to make your own commits. So making a commit always involves 2 steps. In RStudio, it's very easy, but just to mentally think about it, you should have in mind that it's like a 2-step process. In RStudio, this might feel like just one thing that you do, but technically and like conceptually, it's a 2-step process. And so you have this thing here, this graph here. Let's have a look. So you have the working directory, the staging area, and the repository. And the working directory in this context is just the actual files that you work with. So if you open the folder, or if we go to RStudio again, this here is the working directory. So the actual files that you are working with. And then you have the staging area and the repository. So this is more of like a conceptual thing. I mean, those exist technically, but you don't see them typically, or you don't interact with them as with your files. So the staging area, you draft your commit and choose which of your changes you want to save in Git. So if you remember from like half an hour ago, a commit, you can have multiple changes in one commit. So you don't only save one thing, but you save multiple changes potentially. You can also just only save one change, but you typically save multiple changes. So in the staging area, you can draft your commit. You can say, okay, I want this change, I want this change, I want this change, but not this change. And then you don't include the letter in the staging area. And then this is called Git adding or Git add. And then once you have drafted your commit and you're like, okay, now those are the changes that I want to save in a commit, you git commit and you save your commit to the repository. And now this is a bit, the terminology, I put it in the footnote, is a bit fuzzy because we also call the GitHub page the repository and the folder. So this is not ideal in my point of view, but what the author of this book, what they meant is that they meant the Git folder inside your folder. So if you go to RStudio, maybe, I don't know whether you can see it, but I have my settings so I can see hidden files as well. So here's this .git folder, and here everything which is under the hood of Git is stored in this folder. And you don't typically open this folder. Please don't mess with it. Never interact with it directly. But this is where Git will store your commit and has all those snapshots. So this is just how it works under the hood. And so how do you do this in RStudio now, right? How do you draft a commit and how do you make a commit actually? This is very easy in RStudio because you go to the Git pane and then you click on the commit button, and then there will be an extra window which will magically open. And there you can tick the checkboxes and select the changes that you want to add to your commit. And so kind of the ticking of the checkboxes is adding something to your draft commit, and then hitting the commit button is actually doing the commit. So it's very convenient in Git. And so this is what I meant when I said it probably doesn't feel like a 2-step process because it's so convenient, but it actually is a 2-step process. So you first draft your commit and then you commit. So let's do this. First, like we don't need that. So this is like the hands-on exercise. Change the README file, readme.rmd, just put some text in there, or I don't know, if you know Markdown, you can also put a header or some bold text, but you can just put some text in there, save it with CTRL save s, and also create a new file called test.r with a simple print, just print hello world, something like that, and then only commit the new file. So don't commit the changes to the README. Yeah, so that's the exercise. But before you start, I forgot to tell you. So if you are in this window here, you will do something, and then you need to include a commit message. So it won't be able to commit. You won't be able to click here. So yeah, add a commit message. Type something in here, something meaningful, and then commit. Okay, going back to the exercise. Make a commit. So like maybe 2 minutes, I guess.
Just a more general question. How often do you recommend committing? So because when I work, you will go to that? Okay,
yeah,
perfect. Sorry.
That. If you have any problems, also write them in the chat, right? It's always a bit weird if it's not in person and only online, and I have only very limited feedback to whether I've lost some people completely. So has it worked? Maybe people could give some feedback with the thumbs up or the okay, Michael wrote something. I think the commit worked out without committing the README, but the file does not appear if I look at the Git rep. Yeah, that's to be expected. I will talk about that. Okay. So how can you how can you validate that it has worked? You can have a look at the history, for example. So here something should show up now. Some more commit. Another commit should show up. So this should have worked, I hope. Okay, great. So you made your first commit. Ta-da, ta-da. So let's have a little quiz. So here, this is like the local workflow, right? So we'll have a laptop, and then something happens, something happens. Any ideas what 1, 2, 3 are? suggestions in the chat. I should have made a Mentimeter for this, I guess. You can also message me directly if you're too shy. Okay, 10 more seconds and then I will resolve. I mean, hopefully those two should be like, okay, maybe it was too big. So here something with the files happens and they end up in the staging area. So what would this be? And then we have something, and this is kind of Git. Okay, I will resolve. Okay, so first you do something on your laptop and you change some files. So you edit them, you move them, you delete them, or you create a file. And then you add them to the staging area and then commit to Git. Okay. I'm just thinking whether I will come to the slide to answer Cosima's question. I guess so. Or did I? Let me, yeah, here, there it is. Okay, good. Now I got this question. It doesn't show up on the Git repo. Okay, I guess the person was asking about the GitHub repository. And indeed, I mean, I can also make a commit, but you can also go to your own git-tryout repository and you won't see the new file. And why? I mean, you committed, right? Okay, but this is now the case where what I mentioned in the beginning, that Git does not have like an automated sync. It's not automatic. You always have to actively do things. And so this is what I want to talk about now. And this is the sync is related to two terms again. So we had add and commit, and now we have push and pull. And I hope this is quite easy to understand what is what. But yeah, first just one mini slide about Git hosting. So we talk about GitHub here, but there's also GitLab, which is the other main Git hosting cloud platform. So this is also a good alternative, especially for universities, because you can also host it yourself. And it's basically the same as GitHub. So maybe your university, maybe the University of Mannheim actually has a GitLab instance. I don't know, might be something to have a look into. Okay, but let's talk shortly about Git local and Git remote. What does that mean? Okay, local is what is on your laptop and remote is in the cloud. So on GitHub in this case. And you typically only have one remote, which is called origin. This is just a special name in Git. In Git terminology, it's always called origin. And this comes back to what I said in the beginning. So a repository, it's not like Dropbox, where basically the cloud is kind of like the, I don't know, the cloud is where the files are, and then what happens locally is just like not synced or synced. So it's in Git, it's like the repository actually lives at different places. So this is why it's also called distributed version control system. So you have your collaborator could have one local copy. You have a local copy. Git has a remote copy. So it's a bit different. And you can also see that because now if you go to the history, in R, you should see something like this. So here it should say, the initial commit should say origin main, origin head. I will also go to my RStudio to verify. Yeah, here it's a bit, it's too small. Let's put it on a different window. So here it says origin main, origin head. If I made a commit now, let me also make a commit really quickly. Okay, if I go to the history now and refresh here. Okay, now I see, you should see something similar, right? This will be only shifted one more. So origin main, origin head is what is on GitHub. That's the current state on GitHub, is always origin main, origin head. And then you have head itself, which is always what is on your machine, on your local copy. And so this is why also the file does not show up on GitHub already, right? Because it's only on your local machine. So this commit that you made, it's not already on GitHub because you haven't actively pushed it there. So it only lives here. And so this is a nice, I didn't understand it for the first, I don't know, 1 or 2 years, what this means, origin main, origin head. But this is always a good way to see where the GitHub is at, and then the head itself and refs head main is where your local copy is at. And this is can be, especially if you work with multiple people or branches or whatever, it gets more complicated. This is a very useful thing to remember. Okay, but now how do we get our commit to GitHub? Because that's what you're wondering probably. So you actively have to download and upload commits. And yeah, I hope it's quite easy to understand. Git pull means download commits, and git push means upload commits. And in RStudio, there's again, there's buttons for that. So there's a blue button down, and then a green button up. Just for reference, I also put the very easy command line commands, git pull and git push, because sometimes that's just easier, in my opinion, to just quickly do that in the command line. And so the next hands-on is just push. So find the button, the push button, and push. And I will also do that, because then I can show you that it actually worked for my repository as well. But it has disappeared. Why? Okay, you by the way, you find them here, and you can also find them in this commit window here. Okay, I push. And it should have worked. If you haven't set up your authentication correctly, then now you will have some problem, and you might have to troubleshoot that later, but hopefully it has worked. And yeah, it's a bit weird that RStudio does not close this automatically. I always feel like, oh, there's an error or some sort, but if it doesn't say something about an error, it has worked. Okay, so something we can now also have a look at the history again and see that the origin main, origin head thing, which is not visible completely here, has moved up to the green thing. So this is now kind of at the same place. And we can also check that on GitHub now. If you go to your own repository, I will also try to find my repository. And I refresh. So now I only have the README and the test.txt. But if I refresh now, I have the git ignore and the R project. And you should have your test.r file now on GitHub. Has it worked? Can you give like a feedback with the thumbs up? Yes, that looks nice. Oh, very nice so far. I mean, some people, but the people were engaged. Yes. Okay. Good. Cool. So now you've already pulled something, pushed something, and now we don't. I mean, what we can do actually, let's do that, because we don't have a collaborator here, but maybe we also want to pull something down. let's all add a file. So we can, if we are in GitHub here, you can actually also create files on GitHub. I mean, I don't recommend this too often, but let's create a new file. And let's say test test2.r, because yeah, I want to go back to my university days where I have test and test2. So I say let's and commit. Or you can also just write something in, doesn't matter. And so this also works that you can make commits in GitHub directly. I don't recommend it, but you can, for example, if you edit the README, that's something that I do quite a lot on GitHub actually, if it's just something very small. Okay, if you have this now, you can also go back to RStudio and go to the history again and refresh. Or we probably directly pull. So let's all push the pull button now and pull something down, and it will do something. And then it will say fast forward, and it will also say test2.r, or however you called your file, has been added. And now there's also a second new file is also on your machine. So this is how you get down the new commits. Great. Push and pull. No, there's no way to selectively pull. No, that's not possible. Because it's not file based, it's commit based. So at least as far as I'm aware, I mean, it's not an easy feature at least. So yeah, you can't selectively pull files down. But that's not such a big problem, because if you think, I mean, because then if this would be like a problem, then you might have to change your Git workflow, right? If you feel like your collaborator is doing something which you don't want already, maybe they should be working on a branch, right? Because it's not ready to be integrated into your version. Or maybe you need to be working on a branch. Or you can also work in 2 different files. I mean, that's not what Git is for, but there are also more pragmatic approaches. You can also combine workflows from your old workflow live and have 2 different files, and then later manually copy paste them together. That's not the idea behind Git, but that's also something you can do. Okay. Now I think I want to answer Cosima's question a bit. Yeah, but so the pull, commit, push workflow. So whenever you come back to your computer, you should run git pull first. That's always to get all the updates from your colleagues, because again, it's not automatically, you always have to pull them down. So you always do that when you come back to your computer, you make a git pull. And then you commit, or you work and you commit. And how often should we commit? This is what Cosima asked. And that's a very, I don't know, controversial, not controversial, but yeah, it's a bit like a matter of taste. I would say rather commit often than, I don't know. So don't only commit once a day, I would say, because then the risk of, I don't know, accidentally losing some code, that's too high. But also don't commit after every line of code. So maybe if you have written like a nice function, or you've completed like a step in your data cleaning, which feels substantial, or you've written down a model or some text, then make a commit. And not only at the end of the day, but yeah, maybe, I don't know, how often do I commit? I have maybe in 1.5 hours, like 3 times, something like that. But it all depends, right? Sometimes, especially if you have to make very small fixes and you don't mention it, then you might have very many small commits. Yeah, but don't have like huge commits where you have like 10,000 files have been changed, and yeah, so rather commit often, I would say. And then push every other commit. You don't have to push every commit individually. You can also have 2 or 3 commits or 5 commits and then push. But yeah, don't wait too long. And also don't be shy to push intermediate work, I would say, because that's also something I see quite a lot, that people are like, oh no, it's not finished yet. I don't want to push it. It's not perfect already, but that's not, I don't think that's the point of collaborating on code together. This should always be something where you should feel comfortable in pushing intermediate code, and then your collaborator can also have a look. And if you feel like it's really not ready at all, you can also put it on a branch first, and then you can push your branch, because then you also have a backup of your branch, of your code on GitHub, because that's also something that we should keep in mind, that doing backups is also just very good for our own peace of mind. We don't lose code, it's on GitHub. Yeah, so this, if you feel, you can always work with those branches, which are kind of like what we won't cover today, but it's a very good feature for this kind of situation. Okay, to have a look at our quiz. I think this should be rather easy. So again, we have added, this is like the local workflow, and now we have introduced push to upload commits and pull to download commits. Great, 15 minutes left. Let's talk a bit about what can go wrong. And I have to drink a bit because things will get a bit messy now. Because of course, it's not always as nice as it is if you work on a git tryout repository. Excuse me. And the first thing to know is that you're not alone if something goes wrong with Git. Git is a very complex and very advanced, not very advanced, but it's a very, it's not Dropbox, right? A lot of things can go wrong. Because it's a very powerful tool, but that means it's also, there will be also situations where you mess up or something goes wrong. And you're not alone in this. Everyone has those, they're called Git fuck-ups typically, and they happen quite a lot, and it's always very frustrating, but retrospectively also very funny from time to time. Okay, but so you're not alone. There's actually also this page, I think, which is very good. Oh shit, Git. I think there you can find some common scenarios, what can happen, what can go wrong. And what I always say is, as long as you don't push something, everything is okay, kind of okay, because it's not, you have not messed up your GitHub repository, right? It's still, everything on GitHub is still fine. And this is also a nice comparison to like Dropbox. If you delete, for example, if you delete everything on your machine, and if you push it accidentally, you will still be able to recover it from the history. But yeah, please, I would say if it's something, if you feel like, oh, I can't do anything anymore, I can't commit, I can't push, I can't pull, don't try to force something. There are also commands like force push. You will find those on Stack Overflow, just put, and they will say git push -f, and this means force push. But yeah, don't do that, because this can be like this can be a bit messy, and that can also be very messy for your collaborators. So don't push things if they are messed up. And if they are really messed up and you don't know what is happening, save your code, copy paste your files outside the repository, outside the folder, and clone the repository again and copy back in your files. And this is like this is something that everyone has done, and there's no shame in that. So save your files outside the folder, delete the folder, clone the repository again, copy paste in the code, and make a new commit. And this is like the the solution if it's really, really messed up. But it can be worthwhile to really try to understand what's going on when Git is complaining, because that's also when you learn a lot about how it actually works. So I did a Twitter survey a couple of weeks ago where I asked people, how did you really learn Git? And I learned it by reading, but several people also commented something like, I learned the most about Git when I had one of those Git fuck ups and I really dug into the problem and tried to understand how it works. Okay, and read the error messages. They can be quite useful. Copy your files somewhere else and stash. There's also an option, but this is not. This is just one tip I have. Okay, let's talk quickly about the most common type of thing that can go wrong, which is called a merge conflict. A merge conflict occurs, or they occur when competing changes are made to the same line of file, or when one person edits a file and another person deletes the same file. And what happens here? So so typically the workflow is something like this. You work on your laptop and you do a commit, and then you're like, okay, now I want to push. And then Git says you can't push, you first have to pull. That's something that Git says all the time, because it always wants you to pull the changes of your collaborators first. So you do that, you pull, and then your coworker has changed something that clashes with your changes. So they might have edited the same file. That's the most common one. And then Git is like, I don't know what to do, right? Because Git is very clever at combining things and finding out at combining changes. Typically, it's very, very clever. But in this case, it's just like, okay, this is now on the same line. So what should I do, right? And then you really have to solve those merge conflicts. And you have to decide what to keep. And there are several options to do that, to solve those merge conflicts. The first one is to edit the files manually and look out for what is called conflict markers. And I've linked to a page from GitHub, I guess, where they explain it a bit more in detail. The gist is that conflict markers are those things here. I will talk about them on the next slide. So you will have to look out for those and then edit this manually. You can also use a merge conflict tool in the command line. If you're one of those people who like to work in the command line, you can look at Git merge tool. Then Visual Studio Code has a very good integrated merge conflict tool, which is very nice in my opinion. I've linked like a YouTube video, I think, where you can that you can watch and see how it works in Visual Studio Code if you use that. Other Git GUIs, like dedicated GUIs, like GitHub Desktop, might also have something like that. Important to know is that like a file can have multiple conflicts, but yeah, you will see that. I mean, you will see when you will have multiple merge conflicts. Okay, how does it work in RStudio? Unfortunately, RStudio does not have like a proper merge conflict tool. That's one of those features which I'm missing in RStudio. So you have to resolve them manually. So you open the conflicted file. Git will let you know if you have those conflicts. And then you kind of look out for those ones here. So for those conflict markers. And what do they mean? So your current changes will always be denoted by head and those ones here. Then your changes will be in line. And then there will be like the separation thing with the equal signs. And those will will separate your changes from the incoming changes. And then the incoming changes will be there, and then end of incoming changes, blah, blah, blah. Okay. And then you just delete them and choose whatever you want to choose. You can also write something totally new and save, add, and commit. So let's think a bit about that, whether we want to do this now. Yeah, I mean, how quick are we at making commits? Okay, let's try it, right? Okay, everyone go to the README, go to your repository. I have to find mine on GitHub. And go to the README, so to this file, and then edit, click on the pencil thing, and then you type in the second line, I don't know, hello, and you save it, committed. Okay, so now you have a commit on GitHub, hopefully. I will show you. If you don't want to follow anymore, that's also fine. You can just have a look at my at the stream, and I will do it. You can observe. So I now make a commit on my RStudio in the same line. So I add a new line to the README, and now if I try to push, it will tell me error, failed to push, updates were rejected because the remote contains work that you do not have locally, blah, blah, blah. You may want to first integrate the remote changes, git pull before pushing again. So now I push, and now it says, conflict, merge conflict in readme.md, automatic merge failed, fix conflicts and then commit the result. Okay, and now it's like orange, very dangerous. And now it looks like this. Okay, so here's what I have locally, the head. And then this is what I have locally. This is the separator thing, and this is what is on the cloud. And now I can say, so, and then I click here again to delete stage it and merge conflict, solve the merge conflict. And then I can push. And of course, it's not as easy in real life because you will have multiple merge conflicts. You will have multiple files with merge conflicts potentially. So, but yeah, the concept is always the same. It just can be very overwhelming. But yeah, just work through the files and yeah, just keep in mind the head is what you have, and the other thing is just what your colleague or the cloud has. Okay. Yeah, I left a lot more slides in the presentation just for you to have a look at. I have those slides anyway, so I thought I might as well leave them. There's some slides about issues, about branches, branches workflow, pull requests, some miscellaneous stuff. Yeah, this I want to just briefly mention the git ignore file, which is also very important because you might have the case where you are like, okay, I can't upload my data to GitHub because it's sensitive data, it's GDPR data, GDPR relevant data. And then you can use the git ignore file, which is also created by RStudio. So it's here, this file here. And this will, if you put something in the git ignore file, Git will know I should never include this file in Git. And so this is especially useful for sensitive data, user configuration files. So for example, rproj user sometimes created, and we don't want to have this on GitHub. And yeah, there's just Google how you operate this, but it's just a list of files, and you could put or folder. So you could put something like maybe data raw in there, and then the whole folder raw will not be added to Git, and you can't even, it will not show up here in this list here. And so it's very safe, and you won't commit it accidentally if you use the git ignore file. If you have accidentally committed something to Git, you can also remove it again, but it will be still in the commit history, and then you will have to search for some advanced tools to remove it from the commit history if it's like really not good that it ended up there. Okay, recap. What did we learn today? Fork and clone. Fork not, but clone. You made a commit, not on the command line, but in RStudio. You pushed and pull commits. You solved a merge conflict, maybe. And the rest we couldn't cover. And that's it from my side. If you need help, you can always contact me. I work at CorrelAid until the end of 2021. If someone knows about some cool opportunities afterwards, let me know. But I guess I won't be coming back to academia, but maybe some of you have some friends, I don't know. Yeah, you can find my GitHub, GitLab, if you want to have a look at my repositories, my Twitter handle, my website is not here, which is bad because there you will find the slides, but I already posted that in. So it's free.codes. And yeah, check out the README of the Playground repository at the end. There are some resources. And yeah, I think this one is a very good read if you are not sure you understood all the concepts already. And yeah, then I thank you for coming. I hope everyone is not too exhausted now. I feel a bit exhausted, but yeah, I hope you have a nice rest of the day.
Thanks so much for walking us quickly through the comprehensive topics, and thanks everyone for joining. Yeah, there's not so much left for me to say. Just thank you. It was really good.